Good evening, everyone. Dear authors and invited guests, I am Riddhi Gohel, moderator of this session. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome in 7th International Conference on ICT for Sustainable Development through the Zoom. We hope you will enjoy this knowledgeable and interactive session throughout the day. There is a special note for the presenter. You will be given 7 minutes for your presentation and 2 minutes for the question answer. On 7 minutes, I will raise a gentle reminder. So please stick to the time limit. So just before we get started, I would like to introduce to all our chair of the session, Professor Samiksha Shukla. She is an associate professor in Department of Data Science, Christ University, Lausa campus, currently heading Department of Data Science, Pune, along with mentoring AI and healthcare projects in association with a professor from Stanford University, and her core expertise in computational security, artificial intelligence, and healthcare domain. Hello, ma'am. We are welcoming you to in this session.
Thank you.
Yeah, so we can move our first presenter. Our first presenter is Arvind Vishunthala. Paper title is on stormwater drainage to prevent water lodging.
Hello,
Yes,
madam.
sir. You may. Yeah.
Am I audible?
Yeah, you are audible, sir.
So is my screen visible? So folks, my topic for today is stormwater drainage to prevent water logging. See, generally what we have seen is in our rainy season, we have this kind of water logging all over India, right? So what happens is, it is not uncommon to have several parts of the city inundated during heavy rains when heavy rains and thunderstorms lash the city. So lots of cars and buses are stuck in the traffic, and there is no proper planning, and municipal corporation is not able to clear the water logging. And sometimes there is uprooting of trees and disruption in electricity also, right? So use of properly constructed drainage is what we are going to address in this particular presentation today. So can you see an inundated road here? And can you see there's a traffic cop? And generally in this kind of a situation, what happens is you open the manhole cover, right? So that water can go inside the manhole. And what really happens is people and property can be washed away into the manhole. So this is a very dangerous proposition, right? So what we are proposing is there is a regular way of constructing your drainage as of today. And this is being shown in figure 4 here. And on top of it, there are inlets to the roads, right? So this is in this kind of a thing, in this particular pit which we have, we are proposing that we put a drainage pump. So this is the pump. And what happens is generally all areas in a city are not at the same level. There are some areas which are at a higher level. There are other areas which are at a lower level. So what happens is water accumulates in the lower lying areas, right? And what we need to do is we need to have some kind of a drainage where we have a pit like this. And there are perforations on top. This will be covered. And inside this, we install a portable dewatering pump. And what we do is this is run by a finite state machine, and it has two states. One is for the pump and one is for the tank. And this is the software which we use for controlling the pump. And this is the internal structure of the pump. So what happens is there is a submersible pump which is connected to a wireless transmitter, and this is sent through narrowband Internet of Things, which has high penetration coverage and low energy consumption. And then what really happens is there are several such pumps which are installed all over the city, right? And each one of these pumps can be in operation and it can break down. So what we do is we install sensors on the pump, and we connect them through narrowband IoT. And what we do is this data goes to the cloud, and analytics is used to collect this data, and we get intelligent information about the assets, right? So can you see there is a water pump? This is controlled by a microcontroller. This is given to a narrowband IoT. Eventually, this data can be controlled by a central mobile phone, and you can have a man-machine interface where you can see all these nodes on a GPS map. So this is the mobile phone. So what we have sensors which send data, and we can also monitor the status of any one of these pits in a man-machine interface, right? So this is the mathematical modeling. So we have d storage by dt is equal to inflow minus outflow. And eventually, if I solve this equation, I get dh by dt is equal to so much. So can you see if I plot theoretically the curves, this is the curve for the inflow and this is the curve for the outflow. And what happens is this is sensor data, right? So the blue one shows that the pump is working. Red shows that the pump is broken, and sometimes from the broken, it can automatically recover if a reset happens. So what happens is it gets into the recovering state, right? And this is a time series data of the condition monitoring of the pump, right? So what we do is we monitor the pump into three states. One is normal, the other one is broken, other one is recovering. And then what we do is we make a recurrent neural network. And what we do is we do back propagation. And what we do is to prevent vanishing gradients, we use an LSTM. So what is with this intention of what we do is we have a new system for the removal of water from the surface of the road so that we don't get into this problem of drainage, right? So the above method creates safer roads by keeping underlying road structures efficient, and this increases the bearing capacity of the drain. This is in brief my presentation. Any questions?
Audience, anyone has any question?
No, ma'am. I think not.
Okay. Yeah. So, sir, it is really a very interesting project which you have worked on, and it has social relevance also. I just want to know whether you have experimented it somewhere.
I've been experimenting only with a small portion of it in my laboratory. What happens is I don't have funding for the project. In trying to propose this project, I am trying to sell it to some kind of a taker who can finance it so that I can make a prototype and make it popular.
Okay, okay. So, which tool you have used, software tool?
I've used Python.
Python you have used.
Yeah.
Okay. And how effective, like what is the final result of the model which you have built?
This is what I'm showing now. This is the final result. And what we have done is this is my inflow versus outflow. And these are my equations. And this is my sensor data, right? This is
So
my
can you
sensor
show
data.
me the equation?
Yeah.
And which type of sensors you are using, sir?
I'm using temperature, pressure, and vibration.
Okay. So where exactly your lab is?
My lab is in my college, right? I am a professor in a college. And my
Which
lab is
college you are working with, sir?
I'm working with Gokraju Rangaraju Institute of Engineering and Technology, Hyderabad.
Okay. So you have a model, simulation model ready in your lab?
Right.
Okay. Nice project, sir. So I am also interested knowing that something is happening using Python, because I'm basically from computer science, and you are utilizing it for other domain also. So this is something good to know. Thank you, sir.
Okay, madam.
Yeah.
The next paper is also mine.
Yes, sir. Sure. So again, Arvind Vishun Bhatla and her his paper title on augmented behavior realization.
Folks, I hope my screen is visible. My paper is augmented behavior realization. See, generally when we see a human face, we see different types of emotions: happiness, sadness, anger, disgust, etc. Right? So whenever we meet individuals face to face, we interface with their assumed behavioral disposition. Right? See, they put up a face which is not actually what they're feeling. Right? So our brain continuously, whenever an individual is identifying this kind of a face, our brain continuously gathers data, knowledge, perceptions, and classification data, which we call as intuitions. And whenever humans classify any one of these, this we call as judgment. The human face provides the most significant clue to a person's emotional state. So with the advancement of artificial intelligence, these states can be coded in a neural network, and the judgment can be obtained using an automatic decision support system. So with machine learning, a predefined pattern classifier engine can decode the facial patterns. Once we have decoded the facial patterns, what we can do is we can augment this deciphered pattern and morph an image on a computer to predict what is the future behavior of this person, right? So can you see, this is a picture, there is a masked expression, right? And what we do is, these kind of expressions, they shift culturally from place to place. And then what we have is, we have the basic task of deciphering an emotion with the help of a computer. So what we do is, we ultimate objective is to run this on a kit which has an ARM Cortex and a RISC processor and a CNN accelerator, right? Okay. So what happens is, we need to be able to use a set of features, and from these series of features, we need to be able to classify emotions like happiness, sadness, disgust, fear, etc. And what we do is, we have a whole bunch of training data and a testing data. So a whole bunch of data set is divided into training and testing, right? And we have expressions of the person, the signature of the person, the characteristic of the visual configuration, and stuff like that. And then we have a pattern database. And what we need to do is, we need to predict the behavioral scenarios, right? And what happens is, we write Python code. So we have Python code like this. We have imports, and we import the various models. Then we plot loss and accuracy curves. And then we have something like training data and test data. So we have something like 28709 images belonging to 7 classes for training, and 7178 images belonging to 7 classes for testing, right? And then what we do is, we make a model. So this is going to be used, we are going to use a convolutional neural network. So what we have is a convolutional layer, a ReLU layer, max pooling layer, 3 such layers. And after that, we flatten our model, and then we use a softmax to classify the various categories. So what we do is, we run our model, and what we do is, these are epochs. So we train our model for 50 epochs. Can you see this? And then what we do is, we plot this is epoch, and we plot the model accuracy, and then we plot the model loss. Okay, so now what we do, we feed in an actual data, right? So what happens is, supposing this is a salesman, right? And he is going through a sales pitch, and we know that he's trying to deceive you, right? So what we want to do is, we want the machine to be able to classify. Or supposing there is someone on whose behavior we want to comment, right? We can get previous videos of his conversation and give it to this classifier, and we use, so supposing there's a Modi, it will automatically, as the video is playing, it will automatically classify whether he's angry or fearful or sad or neutral. So basically, when you play a video, you can find out through the video whether someone is happy or sad or something. Then what we do is, once the machine gathers the model, we augment this thing and create an emoji, right? And the model which we are using is categorical cross entropy. And key objective is to be able to run it on this kind of a kit here and use it for commercial applications, right? So we apply convolutional neural networks using back propagation to train the weights. Sometimes CNN are prone to overfitting, and we can increase the speed of this model by using GPUs, right? So study of facial expression has many aspects of computer simulation. So several questions and expressions are still unanswered and relatively unexplored. We need to explore them in the future work, right? And these are my references, and I'm open to any questions, right?
Anyone has any question? Sir, what are the features you have used?
I've used these sadness, happiness, anger. I've shown you these features, right? Just 1 minute.
Yes, yes. So what is your data set?
This data I've got from the net.
Which data set you have used, sir?
I don't remember, but this data set I got from the net, right? So for training and this thing I've got from the net, but then the formulation of the problem is mine, and working out it is also mine.
Yes, sir. So what my question was, like, see, you would have taken data from internet. So
Yeah,
whether you have got a data processed data, or you have cleaned it and then used.
I got processed data.
You have got ready data. And there are, like, when we deal with this facial or image processing type of work, sometimes there are some algorithmic biases. So have you thought of that during in your research work?
No, I have not yet thought of that in the research work. I basically did a quick and dirty presentation of my work. And just at that point in time, this conference thing came up. So I just presented my paper.
Okay, so I think you can think of, because sometime because of algorithmic bias, our result get wrong. So you can maybe think of that. And another thing is this. I have a curiosity that, see, sometime in general also, people are sad, but their face, they show happy face.
No, but see what happens is we are learning it over a period of time, right? So they can't hide. They can hide their emotions for a very small time. That is why what we do is we run it through a series of data. So if you run it for a short set of samples, if your training data is small, you may get wrong inferences. But if your training data is large, you will get accurate predictions.
So what was your data size?
It is this one, 3.1. This one. Show this. See this, 28709 plus 7178.
Okay, sir. Thank you.
Thank you, sir. Our next presenter is Runal Domane, and his paper title is on secure messaging application with live translation and privacy.
Am I audible, ma'am?
Yes, you are audible, sir.
Is my screen visible?
It is visible. Can you please make full screen?
Yeah.
Yeah, perfect. Go on.
Greeting for the day. Hi, I'm Ronald Domne, and undergrad at GHRCE. And my co-author is Dr. Ashlesha Nagdiva, ma'am. And I'm here to present my paper titled Secure Messaging Application with Live Translation and Privacy. So according to the statistics, only 20 to 28% of the world population is able to communicate in English, and English being the most popular and professional language, so it is preferred. India is a home to total of 121 languages, which include 22 official languages, and other rest of the other languages are mother tongue. And it is not quite possible to communicate in even like 5 or more languages. As we know, instant messaging applications are one of the upcoming ways of communication, both formally and informally. They have many facilities which makes our day-to-day life useful, day-to-day task useful. And some of them are peer-to-peer messaging, group messaging, multimedia sharing, and etc. With many facilities come another limitations that it provides partial security. Partial security in terms of unauthorized screenshots and screen recordings, and message cannot be translated in application itself. Either we have to use third-party application, or we use Google Translate, which is the most popular translator available out there. So taking all these points into consideration, we have designed and implemented an application. The main goal of this application is to provide messaging functionality with the translation feature, which can translate the message from English to Hindi and vice versa for the time being, and maintain privacy by blocking screen recordings and screenshots as per user discretion. So for our literature review, we have considered few messaging applications and research paper in the similar field. So first is WhatsApp. As we know, we use WhatsApp in our day-to-day life, and it is the most preferred and popular messaging application. There are a number of tasks that can be done using the single application, like we all know instant messaging, multimedia sharing, and even payment gateways. Second is Snapchat. This application is similar to WhatsApp, but it focuses more on private photo sharing and messaging. It notifies the users if someone has taken a screenshot of their chat box, and it sends the notification. Third is Google Translate. Like we all know, it is the best translator out there. It can translate to many languages, either through text or voice, and it even has an OCR, which stands for Optical Character Recognition feature, that allows users to understand text by pointing by pointing the camera at them, which are not in the native language. Our first reference research paper is Android Live Text Recognition and Translation Application using Tesseract. A translation application using Tesseract Leptonica for OCR, and Google API Translate to translate the text into the desired language. And it is the practical implementation of related work by Harmeet Singh and Anmol Sachin. Mobile Language Translator, a paper proposed by Sim Liu Fong and 3 others on language translation, which is English to Bahasa and vice versa, for helping the tourists in their country with hassle-free communication. The proposed work is intended to overcome the language barrier among the tourists. So let us see how our application works. And this is the simple flowchart that I have made. This flowchart shows the design to implement the messaging functionality along with the encryption and other facilities which we have discussed. So here is the sender. The sender sends the message to the database, but before sending it to the database, the app itself encrypts the message using advanced encryption standard 28-bit algorithm. Then the ciphertext is uploaded to the database, and then the message is fetched by the user using unique ID, which is the receiver in this case. And then the decryption takes place in the app, and the receiver can see the plain text. And this cycle continues as sender becomes receiver and receivers become sender. For screenshot and screen recordings permission, we use Android permissions and flags, and has a similar approach to fetch the permission from the database, as the discretion is with the users whether to allow screenshots or not. So general working structure of AES algorithm. So AES algorithms perform cipher processes on 16 bytes of data. So at a time, the cipher processes 16 bytes. According to the 28 bits, we have used 10-round encryption algorithm. So each round comprises of 4 steps, which are substitute byte, shift rows, mix column, and add round key, except the 10th round, which doesn't have mixed columns. So what a substituted byte does is that this steps implement the substitution. In this step, each byte is substituted by another byte from a lookup table called sfox. Then we have second round, which is shift rows, and each row is shifted a particular number of times. Like row number 0 is not shifted. Row number 1 is shifted one at a time. Row number 2 is shifted like twice the actual size, and then add round key. Then the resultant, mixed columns. Then similar to we have discussed, each column is multiplied with the specific matrix, thus changing the position of each byte in the column. Then the fourth and the last is add round key. The resultant output of above three rounds is then XORed operation with the corresponding round key. The encryption can be undone easily as the stages have an opposite to it when performed reverse changes. That is the decryption. Service used to implement translation feature. Google MLKit is a mobile SDK that's bring Google's on-device machine learning expertise to Android and iOS app and allows developers to integrate their model without having any prior experience in machine learning or in-depth knowledge. The MLKit translation models are trained to translate to and from English. And if we want to translate between two non-English languages, then English is used as intermediate. This machine learning kit has four key capabilities, which is broad language support, meaning that it can translate between more than 50 languages, which includes German, English, Hindi, Gujarati, etc. Proven language models, which are powered by the same models used by the Google Translator apps in offline mode. Dynamic model management keeps on-device storage requirements low by dynamically downloading and managing language packets. And last is runs on device translation. Runs on device. Translations are performed quickly so that it doesn't require users to send the data to the external database or the remote server to translate, which helps us maintaining the privacy of the users. So these outputs will help us better understanding what we have proposed in this research paper. So here, just we can see, just a minute. We can see that this is the message node and this is the encrypted message, and we can actually see that it is not in the human readable form. Even if there is a security breach in the database, and if the hacker tries to decrypt this message using brute force method, which is the most common, so it will take him or her, like the hacker, it will require 27 trillion plus years to decrypt this message. And the second is screenshot. You can see the user has denied the permission and has not given the discretion. So this is managed by Android flags and permissions. You can see that the blue color line is the Android flag. And these are the outputs of the translation features. So we can see that all features are working fine. Here's the original message, which is in English. And this is the Hindi version of that. And the original message is not overridden by the translation on the database, means the originality of the message is conceived. And after that, and when we refresh the chat box, then we can see our original message. So, and this will help us in better communication and removing the language barrier. So in the intensive efforts towards the creation of this idea shall lead to the application acting as super user friendly and can be successfully translate the text message from English to Hindi and vice versa. As we have discussed before that we are using AES 128-bit encryption technique. So it helps us increasing the security, and many services has been used here to implement the functionality. Some of them are Firebase and Google machine learning kits. This we are sure that with advancing technology and in-depth knowledge, we will be able to advance the user interaction and help them keeping privacy in the frame. And these are my references, and I'm open to questions.
So good work, Mrinal.
Thank you, ma'am.
The thing is, I have few queries related to the encryption you have used. So
Mhm.
first thing is why AES 128?
Ma'am, I have used ES128 because that is the best encryption algorithm. Like not the best, but it is the one of the most used encryption algorithm out there. So like it takes much larger time to like greater time to decrypt the message if we go by brute force or any other decryption techniques.
That is true. So it is widely used, but not the best algorithm, right? So
Yes,
in
ma'am.
your model, you should have thought of using at least the larger block size.
Okay, ma'am. I'll make sure that if I work on this project like again, then I'll try to implement that algorithm. And as a beginner, as like a third year student, it was difficult for me to think of another algorithms which are
Mm.
out there. And this was the algorithm which I knew before. So I've
Mm.
just gone with that.
Okay, and what about this? We already have this encryption model in various mobile apps, right?
Mhm.
And you have gone through literature also. So, what is the advantages your model will provide over those model which are already existing?
In terms of encryption, ma'am.
In overall, yes, because your main concern is encryption, right?
Yeah, encryption and translation features.
Yes.
So of course, translation, we cannot translate the message in WhatsApp or like even Snapchat or Instagram or like we have seen this, but
Mm.
the encryption, the translation is under development as of today. Google is trying to develop an application about that. And for the encryption, ma'am, most of the times what happens is the company encrypts their database.
Mm.
So the data, the message can, that there might be a possibility like the message can be stored in the original form in the database with some relational databases.
Mm.
But in my case, I have already encrypted the message before sending it to the database. So it helps, securing if there is a privacy breach, then the hacker will get the encrypted message.
Mhm. Okay. Because the thing is, if the existing model are there and we are proposing something on the same line, we should do a thorough comparative study so that we'll get to know, okay, where our model will, we can claim, okay, this my model is better at this place. So maybe those things, if you add in your paper, it will be very good.
Okay, ma'am. I'll make sure that I'll take that into consideration.
Okay, thank you.
Okay, thank you, Mrunal. So we are moving our next presenter is Sheetal VK, and paper title is a study and analysis of algorithm on intelligent system to recognize handwritten digits and characters.
Hello, ma'am. Am I audible?
Yeah, audible, ma'am.
Is my screen visible?
Yeah, it is visible. Can you please full screen?
Yeah. Good evening, everyone. My name is Sheetal VK from the Department of MCA, Nite Meenakshi Institute of Technology. Here to present the paper titled A Study and Analysis of Algorithms on Intelligent Systems to Recognize Handwritten Digits and Characters. Moving to the abstract, this paper is basically a vast survey on different kind of algorithms or approaches to find the most effective or the efficient algorithm to solve this problem of recognizing the handwritten digits and characters. There are many applications of the recognition of handwritten digits and characters. To name a few, some are interpreting postal addresses, check amounts of bank, tax documents, and fill forms. In case of reading the bank check amounts, we understand that the information on the checks are very sensitive and interpreting them accurately plays a very important role as misinterpretation would lead to complexities in the bank system. Hence, we understand that this basic problem of recognizing the handwritten digits and characters accurately plays a very important role in the real life application. This paper considers many algorithms which would be discussed further. In that, CNN algorithm was to be known to find the maximum accuracy compared to the other algorithms. Moving on to the introduction, first let us understand what is data science. Data science is a domain which applies artificial intelligence, machine learning, deep learning techniques, along with some mathematical tools in order to solve a business or real world problem. A typical data science project is also said to be that which makes use of machine learning or deep learning techniques or any of the data collection, data analysis techniques. Here, since we have chosen the problem is to solve the handwritten digits and characters recognition, here we have considered some of the machine learning and deep learning algorithms to start from multi-layer perceptron to the random forest. In order to gauge this algorithm's efficiency, we have considered the parameters, namely accuracy, execution time. Knowing the accuracy and the execution time taken by each algorithm, we come to a conclusion here which algorithm is most effective in order to recognize the handwritten digits. As we all know, the need for automation has drastically increased over time. So, in order to automate this particular process of classifying the handwritten digits and characters accurately, some of the research papers have taken into consideration for the literature survey. These are some of the research papers among the many that were considered. Moving on to the observation and analysis of the research papers, these are the data sets taken into consideration. Among the data sets considered, it is noticed that MNIST, that is Modified National Institute of Standards and Technology dataset, was mostly considered by most of the researchers. Also, they have considered the parameters as mostly accuracy and execution time. Here, we have observed the algorithms considered by each of the researchers in order to find the most effective or the accurate one. A detailed comparison and study is made on these research papers and also the approaches they have considered. From these 15 research papers considered, this particular one provides the highest accuracy, that is 99.89%. Also, the observation and analysis drawn from this study is that the most used algorithm is the CNN algorithm. And also, this is that algorithm that provides the highest accuracy and also takes more execution time. That is, highest accuracy happens to say that it provides the best effective classification compared to the other algorithms, but also it takes more time to execute. And from the algorithms considered to be CNN as the most, one particular approach is pixel-based and geometrical-based feature extraction that which provides highest accuracy. This particular approach, as said, provides the highest accuracy with the CNN algorithm considered. Also, moving to the conclusion, this paper is basically a broad study on different research papers, and also it makes the recognition of handwritten digits and characters approach in a different way to find the effective and the maximum accuracy one. And here it is found that CNN algorithm is to be more effective, but we observe that we are compromising on the execution time here. So, in order to consider for the future work, one could include on keeping the recognition intact, that is the accuracy intact, and reducing the execution time, or one could try to increase the accuracy and also to find a multi-featured algorithm, that is bringing up other algorithms that is in a hybrid mode in order to solve this problem. Also, one could make use of effective pre-processing methods, that is applying on it for the data set to remove the flaws on the data set to make the recognition more accurate. As we know, data is the pillar for this kind of problems. These are some of the references considered for the study and analysis purposes. Thank you. I'm open to any question. Hello.
Yes, Sheetal, right?
Yes, ma'am.
Sheetal, the thing is, this is a very uh, common, or maybe most of the students try to do this project, and like they come up with different solution. So what is the uniqueness in your paper?
Ma'am, this paper is actually a foundation for future study. It is just a analysis, like a study and analysis of the different kinds of algorithms for the future work one could actually implement it
That's what I'm
to.
telling, madam. So there are many foundation paper already existing. Now the thing is, like, when you claim it to be your research paper, when you claim it to be your research paper, you have to have something uniqueness, right? You might have seen when you are reading literature survey, there are many existing paper with same idea, and maybe we can say there are papers which are having more better claim than your paper. So what like how can you say that your research paper
Hello,
is having some
hello.
uniqueness? Yes, Sheetal.
Ma'am, I could just knowing with my knowledge, I could just say that usually a survey paper includes no much kind of uniqueness, but
Hmm.
also here I could draw one input saying that of course CNN algorithm is used by many and it gives the accuracy results. One
Hmm.
future work one could include is to reduce the execution time is one kind of input I could draw here.
Hmm. So this is a survey paper. That's what I'm telling. See, uh, even if you want to do survey, might be I have like the work which is already done and presented. uh, Either you should have a extensive survey. Okay, so how many paper you have reviewed?
15, ma'am.
15. So don't you think that if you are claiming it to be a survey paper, it should have at least, because it is a most research work, like it's I feel it is coming to somewhat some kind of saturation point, and at that point of time, if you review only 15 paper, will it be enough?
Yes, ma'am. Actually, I'll take this as an input for my future work if I'm doing any research paper, which is like a common topic already worked on. I
Hmm.
will try to include more
Because
research
see,
papers.
from your literature, you should have at least thought of ki, which topic, like what is the gap, what is missing in the existing work, and at least that you should have highlighted.
Yes, ma'am. Actually, from the papers which I've reviewed, one is giving high accuracy, but most of
Hmm.
them are compromising on the execution time.
Hmm. Hmm.
And that is the one point, like as a basis for the future work, as I've given as an input, one would
Hmm.
work on keeping the accuracy intact and also reducing the execution time, as that is playing a major role
So
as many.
have you tested this whatever you are claiming? Have you like how you are claiming that CNN is the best? Have you taken data set and experimented it?
No, ma'am. No, ma'am. As I said, this is like just a basis for the future study. This is just a survey on the research papers. Based on the research papers I have considered, it is found that CNN has the most effectiveness.
Okay. I am not much convinced with your paper. Anyway, it's okay. Thank you.
Thank you, ma'am.
Thank you. So next presenter is Amrut Kumar, and paper title is Intelligent Chatbot for Student Monitoring and Mentoring.
Riddhi, I think this author is
He's,
not present.
yeah, he's in absent, I think. Okay, we are moving our next presenter. So next presenter is Ashoka Kumar Ratha, and paper title is Defect Discrimination of Mango Using Image Processing Techniques. Hello, sir. You may start your presentation, please. Hello. So, Dimple Nanchani, your paper title is Upshiti, a touchless attendance system.
Yes, ma'am.
You may please start your presentation.
Okay, Anisha. I'll start presenting my screen. Yes. Um, is the screen visible?
Yes, it is visible.
I'm unable to start my camera for some reason.
Don't worry. You can go on with,
The presentation. Okay, thank you.
yeah.
I think, yeah.
Yeah.
So, hello everyone. I'm Dimple Nachnani, and today I'll be presenting my paper on opacity, a touchless attendance system. The authors of this paper are Saloni Velonde, Sejal Kriplani, Mayur Pawar, and our mentors are Professor Shashikant Dugar, who is from TIFR, and Dr. Gresha Bhatia and Tiwari, who are from my college, Visit. So we'll be discussing all these in today's presentation. So this is a TIFR and Visit collaboration project. It is basically a research project. And moving on to the introduction. So with the coronavirus pandemic, there were various new technological introductions that were required. We had also adopted the work from home nature, but then we had to eventually shift back to the offline nature, and for this we needed digitization. So the problem with the earlier systems were that even though they were in manual, so the first generation was the manual attendance system. Then we had the technologically advanced system, that is the automatic system. But then these systems were mostly based on biometrics or fingerprint or some other technology which was very expensive, such as the iris scanner. So the iris scanner basically scans the iris and marks the attendance based on that scan. But this technology is very expensive, and this is not suitable for areas which are rural areas of India, of a country especially like India, wherein there are so many villages, so many areas which don't have access to proper facilities. So because of this, opacity came up. So opacity is basically a touchless attendance system, which will be taking the face of the person, and it will be capturing the face. It will be recognizing the face, and based on this, the attendance of the person would be marked. So going on to the literature survey, before starting this project, we had done a thorough literature survey, and these are the various papers that we had referred. Some of them use PCA technique, some of them use local binary pattern technique, Weil and Jones algorithm, neural network. But we found out that there was no one uh, complete system which did all the things that are required in the attendance process. So we came up with opacity because of these reasons. So the algorithm that we're using, we haven't built a proper network on it, but we have a technology that we have built on our own. That is the socket technology based on Android Studio and the Python, which I'll be explaining later. So first of all, the algorithm that is used for face recognition, we're using the DLib library. It is a pre-trained model having 29 convolutional layers. It is trained on 3 million faces, and this model has an accuracy of around 99.38%, which is very good, and we have also tested it. So this is the algorithm that we have used. Going on to the specifications. So unlike the other methods which require fingerprint scanner or some iris scanner, some good and very expensive technology, we just require 2 mobiles and 1 laptop or even a desktop. But we should have a webcam in there. So the camera or the mobiles would be placed at a remote location, and these would be connecting to the laptop, which would be act like a server. So this connection is something that we have built from a scratch, and this wasn't available anywhere. So even though our library is pre-trained, this is something which is unique about our project. We'll be requiring an OS for the application to work on, and we'll be requiring the cameras and the mobiles. So basically, we'll be using the cameras of the mobiles, the front camera, to capture the faces. The software specifications, we have used Python, OpenCV, Daylib, PyQt5 for the front end. Java was used for the socket programming, and the socket programming itself is used. Tools we have used various IDs like PyCharm, etc. We have used Google Colab for training the basic daily model. SQL is used for storing the attendance and the information of various employees and the students of the organization. Local storage of images is also there because in case of backup, we require the actual images of the people. And GitHub has been used for project control, and Android Studio has been used for making the mobile application. The constraints of a project. So even though we have tried to improve the functionalities of a project, there are a few constraints. So the mobile that is used for capturing the video, that is a video stream, should be of sufficiently good quantity. Otherwise, the face detection algorithm fails. And it also depends on the lighting of the environment. Like it should be a properly well lit place so that the face detection algorithm can work efficiently. Moving on to the methodology. So we have four basic modules. First is the GUI model. The GUI of the server, that is the laptop, has been made on PyQt5, which is a Python-based front-end application. Whereas for the Android mobile phones, we have used Android Studio. Database. So for the database, we are using the MySQL database for storing the attendance of the students and the employees. Coming on to the important and the video capturing module, which is the client of the complete process. So the application is first started on the mobile. It is logged in using the credentials, that is the email and the password. And then only the face recognition module starts. This face recognition module captures the frames at 1 FPS. We have decided upon this threshold because we tried multiple values and we found out that at 1 FPS, the system wasn't lagging and it was working efficiently enough. And at 1 FPS, it sends these images to the server. The server, wherein the main Python code is present, it processes these images. It performs the various pre-processing techniques. It it detects the faces, creates a bounding box around the face that is recognizes the faces, and then again sends the recognized image back to the client. And then this client shows the feedback so that the person at the gate knows that their attendance has been marked successfully, even though this server is located somewhere else. So that is the video capturing module and the face detection and the recognition module. So implementation, we have created an application which has dual login. So one is for the administrator. The administrator can add or update the user. We haven't added the delete option because we believe that no information should be permanently deleted from the system. So using the update option, we can make the user inactive. So let's suppose an employee has left the organization, then we'll just switch to inactive. Then we have the add attendance in charge, which would be the person who would be taking the attendance and update the in charge as well. Next, we have the attendance in charge. These attendance in charge are responsible for the attendance of the complete system. They record the attendance. They can edit the attendance in some special cases. Let's say some employee is going for half day, or some student wants to go for some national sports competition. So we have built a generalized system that can be used for any organization, a school, a college, a workplace, anywhere. Then they can also view the records, and also we have added this advanced functionality of viewing the graphical analysis. And then we have the students and the staff themselves, the employees whose face would be detected. This is the implementation. So as I said, after logging from the server side, all the details are encrypted by AES algorithm. So we have kept security in mind as well. At 1 FPS, the video is sent to the server processes it, and the frames are sent back to the client for feedback. And this is the complete process. As we can see, the furthest front camera is started, the frames are sent to the server, then processed image is sent back to the client, and the face recognition is performed. So the results obtained. So as we have used DLib library, the result and the accuracy is around 99.38%. Further on testing, we observed that this model works well even in various lighting conditions, and even when the people have a minor change in their facial structure. So let's suppose I have spectacles. So I have tried it without spectacles and with spectacles, and it was able to recognize me well. Similarly, we have performed the beard test and some other tests as well. Uh, Further, our application is unique in the way we have dual authentication, that is dual login as well. So dual login is for the two types of users, whereas dual authentication is the person when logs into the system, they have to provide their email and password. After this, their face is also recognized and matched. So first, I'll type my email ID. Let's say dimpleneath@gmail.com. Then I'll write my password ABCD, and then when I click on submit, another window will pop up. It will detect my face. It will match the face, the details I mentioned from the ones into the database, and then only I'll be entered into the system. So these are some of the unique features of our system. And this is the evaluation measure. We can see that opacity uses ResNet, and its accuracy is the highest among all the other models and the papers that we had read. And I like to conclude that in the modern COVID-ridden times, opacity works well as an attendance manager, and it can be used for any sort of organization, be it a small scale, large scale, be it in rural or urban area, and thus it is a viable option for automatic capturing of attendance. Um, so our future scope includes that we have implemented this for a single Wi-Fi point, but for organizations which are very big, which have multiple access points, this is yet to be tested. So that can be done in future. And we can also see liveliness detection. So currently, our if someone places the ID card or some photo in front of the camera, the person is sometimes not detected because of the papery nature, but sometimes it is detected. So when we include the liveness detection, it will be more foolproof. These are the references. Thank you very much.
Nice work, Dimple. So in the beginning, you were claiming that it is applicable for rural area, right? Because
Yes,
in rural area, we may not have internet connection.
yes,
So your project is mainly designed for that.
yes, ma'am. So even though we don't need internet, we need a network. So we need a router, but we don't need internet access.
Yeah. So which technology you're using to transfer your mobile video to the server?
So, ma'am, our the mobile application is basically made on Android Studio. So, it is an Android-based application that is Java, and the server is Python. So, we are basically using a socket programming. So, one side is a Python socket, and one side is a Java socket, and we're connecting those.
Okay. And which data set you have used for this?
Ma'am, BGG. So, we haven't used a dataset, but the DLIM model is pre-trained on BGG dataset.
So I mean to say, see, you would have recorded video. Your project you experimented or not?
Yes, we have experimented.
You have experimented, right? So for experimental purpose, you would have used certain videos, right?
No, ma'am. I'll just show you the screenshots. I think that will make it more clear because just a second. I'll present my screen again. So we have also built.
Dimple, are you muted?
Yeah. So this was a cookbook which was made as a DIFR required it for installation purposes. So it has all the screenshots of the application that we have built. So as we can see, this is the add user functionality. So in this functionality, we have tested it with our individual faces. So with the UI of the
Yes, yes,
application.
yes. Dimple, this is perfectly fine. What I am asking is, keep like now I want to give my attendance for today, right?
Yes. Right.
So I'll be recording video. Am I
No, ma'am.
getting?
This is a live feature. So at the entry and the exit points,
Okay, you will be. Huh.
the mobile phones would be logged in by the admin, and they'll be placed at a particular angle, and it can also be handheld. So it is placed at the particular angle, and the students just need to walk in. So what they'll do is at the entry gate, they'll walk in and they don't even need to stand in front of the camera. As soon as they walk in, their live video would be detected. The face would be detected and attendance would be marked.
Okay. So the main feature which you are bringing in over here is we don't need network, because there are many systems which are already existing with similarity, but the thing is they need internet connection and they need
Right.
okay. Can you go to comparison,
Um,
or you just orally tell me ki, what are the features which you say that are really very good contribution over here compared to the existing models, apart from what we have discussed.
Yes, ma'am. So also there is this backup of the images. So within let's say any between any time, if the admin needs to see if actually the student was present, so the images of every time frame are backed up at some instant of time, and these are stored locally. So the local storage is used for this purpose, and this is efficient in case of foolproof. Like I said, the liveness detection is a feature which would enhance the system, but since that is not integrated into our system yet, we have this backup option as well. Further, I think yeah, we have also functionalities which are not usually present in system. Like some system don't take into consideration half days, some don't take into consideration the late timings. We have kept a threshold. So let's suppose if the if the organization starts at 9 a.m. and if someone enters at 10 a.m., then they'll be given a late remark. But if someone enters at 12 p.m., then they'll be given half day. And if someone enters at 3 p.m., then they'll be marked as absent. So these all also, we have kept in mind the minute details and designed the system, which is general as well as specific in some sense.
Very good presentation, Dimple. The best part was like at least your camera was on throughout. Thank you.
Thank you.
Thank you, Dimple, for your nice presentation. So, Ashok Kumar Ratha, can you continue your presentation?
Good evening, madam.
Good evening.
So, my topic is that is defect discrimination of mango fruit by using image processing technique. So, let us start with the introduction part. The mango is the India's most popular fruit and is regarded as the king of fruit. It contributes around 45% of world fruit production, according to FAO stat of United Nations in the year of 2020. In the last financial year, in 2020 and 21, uh, the total mango exported from India was valued at approximately 7 billion Indian rupees, which contribute to the growth of Indian economy. This mango fruit is not only tasty, but also it is having high nutritional value. It contributes around 67% of daily value for vitamin C. So this water soluble vitamin also support to our immune system, iron absorption, encourage all the cell development and repair. Mango is also high in mineral copper and folate, essential nutrient during the pregnancy because they promote healthy fetal development and growth. Quality plays an important role not only for the export but also for the consumption purpose. External distortion damages are caused due to several reasons. As per Mango Defect Guideline 2014, some are stem and ruin, some are dendritic spot, some are anthracite, some are skin cooking and lenticel. All the above deformation are outside imperfection that influence the nature of the mango skin. Let us go for the abstract of this project. Defect discrimination is a crucial factor in evaluating the quality of mango. The flaw mark on the flesh remark about the deformedness of mango fruit. The internal defect of mango fruit is often directly proportionate to the area of flaw mark on the screen. The defect discrimination of mango fruit manually with respect to the area of flaw mark is challenging, erroneous, and time consuming. Hence, development of automated technique for defect discrimination of mango fruit is highly needed. Here, an image processing method is developed to discriminate the defective flaw mark on the skin of the mango fruit into three categories. One is good, average, and bad. The experiment revealed that the proposed method is successfully. Let us go for the proposed method. The proposed approach involves a grayscale conversion, thresholding, binarization, morphological operation. The experimentation is conducted in a HP Pavilion Core i5 laptop, Windows 10, and MATLAB 2021 platform. More than 100 images of mango fruits of different categories are taken to evaluate the methodology. First, the RGB image are then converted into grayscale image. After such conversion, the binarization operation is executed. Here, a condition is applied that the resulted image only contains the pixel value is less than 50. Then clean the binary image to remove the unwanted pixels. Finally, invert the cleaned binary image to get a flaws mark that appear on the skin of the mango fruit. The mango fruit and flaws mark area is calculated by 4 neighborhood connectivity operation and morphological operation. After calculating area, the percentage of defect is calculated by taking the ratio of the area of flaw marks and the fruit area by multiplying 100. Further, the condition is applied to the categories the mango fruit into 3 classes. One is good, average, and bad. Suppose the defect area is less than 20%, we treat that as a good quality. If the percentage of defect lies between 20 to 40%, we treat that one as an average quality. And if it is more than 40%, then we will treat this as a bad quality. So this is the proposed method for defect discrimination of mango fruit. Here, the grayscale, first we take the image of the mango, which is in the RGB image, and we convert that RGB image into grayscale image. Then we convert that grayscale image into binary image, where each pixel value we maintain that is less than 50. Then we remove all the unnecessary spots. Then we invert the binary image to discriminate the flaw marks. Then we calculate the fruit area and flaw mark. Then we divide that one and multiplied by 100, we calculate the defect. If the defect is, whenever the defect is less than 20, we found that as a good quality mango. If it is lies between 20 to 40, we will get that is average quality mango. Otherwise, we will get the bad quality mango. So this is the proposed method for defect discrimination of mango fruit. So let us go for the result and discussion. The mango fruit defect discrimination is determined by executing various operations of image processing. Here, for demonstration purpose, 4 images are illustrated with their operational step. In 4 images, we have taken one has good skin, that is no flaw marks. One is flaw marks with a small area. One has significant flaw mark, and another one has a damaged skin with high flaw mark. So here, the original image, you can see that the first figure, that is mango with no flaw mark. Here, there is no flaw mark is there, and the mango is of good quality. When it processed in the such algorithm, the results show that the quality of the mango is good. Then here, this if you come to the second figure, here there is a light flaw mark is there. So here the algorithm it shows that this is also a good quality mango. Here in the third figure, it shows that mango with significant flaw mark. Here it shows that the average quality mango. And in the fourth figure, here the flaw marks is very high. So the algorithm automatically detect that the mango is of bad quality. Let us go for the conclusion part. The mango fruit defect discrimination is an essential aspect of the fruit industry. The sorting of mango fruit as per its quality to generate the actual value of money to customer demand. This proposed technique is easily detect the defected area, calculate the affected percentage, categorize it into proper class as per the flaw mark. This methodology is really helpful for the fruit industry. And these are the references that I've taken for this presentation.
Sir, so this mango images from where you captured? Am I audible?
Yes, ma'am.
Yeah. From where you captured this mango images, or it is secondary data set?
It's my own data set, ma'am.
Okay, so but with 100 images, do you feel that the accuracy of result will be justified?
No, here what the algorithm is say that we have created the data set of more than hundreds of images, and each image is having of good quality. Some are having less flow marks, some are having more flow marks. Then we simultaneously send those images into such algorithm, and the algorithm is easily detected that which one is good, which one is bad, and which one is under
Exactly,
average
sir.
category.
You need to train it, right? You need to train it. Then only will algorithm will detect. Am I right?
Yes.
So when you train with very less images, percentages of accuracy over the time may not be as expected. So what I am suggesting you is you should use a larger data set.
Okay, ma'am.
And only this marks you are considering for identifying, or is there any other feature which can be considered?
No, here only I considered the flow marks only. Based on the flow marks only, you can discriminate the quality of mango.
But sometimes what happens, the mango in general, what I have observed, I'm telling you that the mango is very flawless, and within a day it become with so many marks will come on it. So if this type of things comes, how can we come up with a solution which can help us to identify? Is there any feature which can identify this type of upcoming flaws, maybe sometime prior to it?
Yes, ma'am. That is another aspect of the research that suppose that means day by day how the mango is degraded. Okay, with respect to the humidity and temperature, all these things. So suppose in the first day it will be degraded 10%, in the next day it is degraded 50%, like this. That is another area of the research. Day by day degradation of the mango.
Okay, okay, thank you.
Thank you, sir, for your great presentation. So all the presentation will. So thank you very much to our all authors and for presentation, for the great presentation and the great contribution to this session. And also I thank participant for participating in this conference. I hope this session was informative enough to all. You, on behalf of the team, thank you for all the supporters for in this version and previous six version. Be happy to have you in previous six version. All the presenter would be getting their participant digital certificates within 2 or 3 working days through the mail. The publication will be live within 5 to 6 months, and already all the papers have been forwarded to the Springer publication. So please kindly cooperate with the team of ICT4SD 2020. And I also thank our session chair, Professor Samiksha Shukla. Thank you, ma'am, for your valuable presence and your kindly information to all the presenters.
Thank you, Riddhi.
So here token of appreciation on behalf of Global Knowledge Research Foundation and Team ICT4SD.
Thank you. Riddhi, I think it was nice interacting with few of the authors. I think few authors need little more guidance so that they can improve upon their work, but it is something which they have tried well. Thank you.
Thank you, ma'am. So there is a no all presenter is going. So can you, Shital, can you please turn on your camera so we can snap over this virtual conference.
Maybe she's not there.
Yeah, not a problem. Then we can end this session, ma'am.
Yes.
Yes.
Thank you. Bye.
Thank you.